Hello, welcome to our discussion of the Java Throwable and its children, error and exception. We're going to immediately go to a diagram of this exception category from the Java Language Reference, Chapter 9. You can search for that. Also, the URL is explicitly there. We're going to focus on errors and checked versus unchecked exceptions. So here's our diagram. Notice object and throwable. Throwable is directly inherits from object, so it's up pretty high in the Java hierarchy. Then derived from that is exception, and that's where our thoughts are centered on today. So exception is a type of throwable, that is, it can be thrown. Within exception, there's two categories, checked and unchecked exceptions. Let's take a look at unchecked exceptions. So unchecked exceptions are all of those exceptions that derive from runtime exception. Here, the philosophy of checked versus unchecked exceptions is really, at least the thinking of the Java language designers is really the most apparent. So unchecked exceptions are exceptions that occur where you can't be expected to recover from it in business logic. That is, the current state of the running code cannot be expected to recover from it. You can be these runtime exceptions are caused by bugs for sure. Almost all of them. All of them are caused by some type of application exception bug. Look at them. Class cast exception. You've cast the incorrect types. Illegal argument exception. You're passing a wrong type of argument. Index out of bounds exception. You run an index past the array, the end of the array. A null pointer exception, very common. You touched an object that doesn't exist, a null object, and tried to dereference it. All of these are caused by application bugs, but how can the business logic recover from it? If the business logic could recover from it, it wouldn't have the logic in the first place. This is not to say you shouldn't do anything with these runtime exceptions. You should log them. Now, the other type of exceptions not inheriting from runtime exceptions, so it's everything else. All of these methods here. Plus, there's methods in the standard library. So say, well, why file IO not found exception is something we've encountered in our labs and in our programming examples, and that's not listed here. That's not a runtime exception. That's a checked exception, but it's not defined in the java.lang package. It's defined in the file IO package. So Java itself extends from the Java standard library itself extends from these exceptions, and most of the exceptions that are in the standard library, and most of the exceptions that you write and you need to design your own exception in your own code should not be runtime exceptions. They should be handled exceptions. For example, file IO exception. That's not considered a runtime exception because you have a possibility at least to recover from that in business logic. Oh, the file's not found. Let's ask the user for another resource. Or perhaps we make up an empty file with default settings, and that will be a file. Like file not found exception can be often found when an application first runs and it needs to set up its configuration files. So runtime exceptions, log them, but you're not expected to recover from them in business logic. In all other types of exceptions, the expectation is that you need to recover from them in business logic. Because you're expected from the Java, from the class libraries designer's perspective to be able to recover from them, the Java language requires you to explicitly acknowledge these types of exceptions. You can let runtime exceptions go without explicit acknowledgement that it might occur. Think about this. If you had a null pointer exception, every time you touch an object, you might generate a null pointer exception. Every time you touch an array, you might have an index out of bounds exception. If these types of exceptions were required to be acknowledged in the top level Java code, that's all the Java application programmer would be doing, would be catching and throwing and acknowledging exceptions. So these type of very common runtime exceptions, expect them just to be logged and not recovered from a business application logic perspective. Now let's take a look at the Java standard error classes. Now let's have both diagrams on the screen for a second. They both extend throwable. So error and exception are siblings of each other. But error is distinctly different from exception in terms of class design. An error means that something has happened to the stability of the Java runtime itself. Out of memory, internal error, Stack Overflow error. Some of these can be caused by programming bugs for sure. Out of memory error, Stack Overflow error. Those can be triggered by application errors. Some errors may represent bugs in the Java virtual machine. Those are mostly ironed out, but some type of external factor, perhaps the native machine the Java virtual machine is running on, has become unstable. Again, this is an error, not an exception, and the application business logic is not expected to recover from it. It can try to log it, but at this point, some of these are even make the logging subsystem suspect of working. Not all, but some. Try to log it, try to find out what happened, but your business application logic can't recover from it. It's not a checked exception. It's not an exception at all. It's an error. Next, we'll look at a simple application, as simple as I could write it, to examine both checked, unchecked exceptions and errors.